All right, we've covered a lot of information, and it's about this time when students start to feel a little brain drain, like all this new terminology about depolarization, repolarization, P waves, T waves, intervals. So if you're finding you need to take a break, this would be a great time. And when you come back, I would even recommend to revisit those sections where things might be a little fuzzy and write down your questions for me. Because we're going to go into now the 8 steps to assessing an ECG strip, and you need to be able to understand what you're looking at in order for this process to go through a little bit more easily for you. All right, so there are 8 steps to interpreting an ECG, and we don't want to miss any of these. So we're going to start with looking at the rhythm of the ventricles and the atria. So looking at the P wave and the QRS wave. Then we're going to calculate the rate of both the atria and the ventricles. Now, what we're showing you here is the normal sinus rhythm. You will find that as we get into some of the abnormalities, there will be differences among these 2 rates and rhythms. And then we're going to look and analyze and measure all the waveforms that we've talked about. So the P wave, QRS, T wave, and then the intervals, the PR interval, the QT interval, and then we're going to assess the ST interval. After all that, we're going to give an analysis. So let's get started. We're going to come back and look at this ECG later today. I do say let's revisit Mrs. Jones' ECG, and that's because when we do face-to-face classes, I talk about this earlier, but this will be an ECG in your booklet that you will analyze after we've gone through all of these steps. So step number 1, is the rhythm regular or irregular? So we're going to start with the atrial tissue, and that's the P wave. You'll notice the calipers are locating 2 subsequent P waves here. And then we're going to just take that measurement all the way across. We always need to make sure that it's consistent throughout the entire strip, and that is because there are some rhythms where it may be consistent for most of it, and then there's a blip. Or it may be inconsistent throughout, and there's some characteristic patterns we'll look for in some of those arrhythmias. In the diagram below, so I do have the video playing, it will loop around for you. I've identified the P wave here. So we got my isoelectric line, P wave, QRS, T wave. New complex, P wave, QRS, T wave. Isoelectric line, so baseline, nothing's happening. Then we have another P wave. And so what I've done is I've highlighted all of those for you across this waveform just to show you what you're looking for. If you need to pause or rewind at this point, go ahead. And you can always come back to this as you're referencing it when you get into your analysis, but this step is in your book. Just as we've done with the P wave, the atrial tissue, we now need to move to the QRS wave, the ventricle tissue, and see if they are also contracting at a regular rhythm. So we're simply just going to repeat that process, but instead of putting our calipers on the P wave, we're going to put our calipers on the R wave, so the very top of the QRS complex. And again, check all the way across your paper. There's only 2 answers that can occur for these 2 stages. It's either regular or irregular. If it's a regular rhythm, we simply note that, a regular atrial and a regular ventricle. Or if it's irregular, you would note which one is irregular. Step number 2 is then to calculate the rate. Now there's multiple ways you can calculate the rate, and I will go over every one of them here. I do show 4 methods, so you can try all 4, absolutely. There will be some rhythms where you will just find one easier than the other. You may just fall in love with one in particular and always use it. That's fine. So we have a 10-second strip, a 6-second strip. We've got the R to R interval method, and then we have a sequence method. So let's start with the 10-second strip. In a 12-lead ECG, when you get this big bad boy printed out and handed to you on the desk, the duration of the ECG tracing is 10 seconds. So that lead 2 that's along the entire bottom is a 10-second picture of the heart. And so here's what you would do is you go back to that atrial. We've already just looked at it for rhythm, but now we're going to count how many P waves we see on that entire strip. And so I've got this one here already labeled out. I have 12 P waves that I can see. It's 10 seconds. I know that in 1 minute, there would be 6 groups of 10 seconds. So I'm simply just going to take 12 and multiply by 6, and this gives me a rate of 72 beats per minute. We're going to do the same exact thing for the ventricles. Just like we did with rhythm, we're going to also count the ventricle rate because that may be different in some arrhythmias. And you count every one that you see. So if there was another one right here starting, I would count that as well. So here again, I've got 12 R waves. 12 times 6 is 72 beats per minute for the ventricular rate. Now the 6-second strip method is the second method we're going to talk about. Those are the bedside printouts that you get, the little small monitor, and it gives you an image like this. What you need to make sure is that you have 6 seconds. And how you identify 6 seconds is there's hash marks. So these I've just cut off of a 12 lead to show you 6 seconds, but there would be 30 boxes in a 6 second. Usually there's a hash mark at 0. Then there's another hash mark at 15. And then you would see a third black hash mark at 30. So you're taking a total of 3 black hash marks, and you know that that will be a 6-second strip. The process is exactly the same, except our multiplication factor changes. If I'm taking a 6-second strip, I know in 60 seconds, in a full minute, there would have to be 10 little bundles of 6 seconds to make up 1 minute. And so what I'll do is I will count my number of ventricular R waves and multiply by 10. Same thing for the P waves, the atrial, you're going to take that number and multiply it by 10. So using the 6-second method, I now get a heart rate of 70 beats per minute. The R to R interval is the third method that we can use to calculate rate. And I do encourage that you practice every single one of these. The R to R interval method of calculating rate can only be used if the rhythm is regular. What we're going to do here is find 2 R waves, and there are 2 methods that you can use for this particular system. Now the first one is using the number of large boxes, and you can count partial. So if you have a half a box, you would count that as a half. You try to find one that is closest to the long or the darker pink line because it's easier than to count. So I'm going to start counting. I'm just a little bit off. So 1, 2, 3, 4. And you can see this one is also just a wee bit off. So I'm going to say I've got 4 large boxes. You take the number 300 and divide it by 4. And that gives me a heart rate of 75 beats per minute. We can get a little bit more accurate here if we use the 1500 method. And that simply means we're going to take 1500 and divide it by the number of small boxes. I know that there's 5 small boxes in 1 large box. So 5, 10, 15, 20, it gives me 75 beats per minute. Now the last method is the sequence method. Again, if it's a regular rhythm, this will work really well. If we start at the R wave, there's no value attached to this first line. It's just simply our start. And then we're going to count down a sequence of numbers until we hit the next R wave. And I've got the sequence written here as 300, 150, 100, 75, 60, and 50. So if I'm starting here, there's no value. This is just my start line. My next dark pink line is 300. So if there was a QRS wave right here, my heart rate would be at 300 beats per minute. There isn't, so we go to the next one. 150. I don't see another QRS yet. 100, 75, and it's just a little bit past that. So we can estimate this to be 75 beats per minute. Now what happens when the R wave is between 2 numbers in that sequence? So we have another strip here. So again, our starting point, no value attached, 300, 150, 175. Oh, dang, it's in between, right in the middle. Whichever two numbers you are in between, so in this case it's 100 to 75, the value difference is 25 points. So I've got 100 minus 75 equals 25 beats in this box in particular. Remember, I have 5 small boxes, so I'm going to divide 25 by 5. And that gets me the value for each small box. So now I know that each small box is worth 5 beats, and I can go from 100 down or count 75 up until I get to this QRS wave. So if I go down, 100, 95, 90. I think my heart rate would be 90 beats per minute. Let's try it the other way. From 75, I'm going to count up 80, 85, 90. Okay. If I was between 100 and 150, that difference is greater. It's 50 beats. Between 150 minus 100 is 50, which would mean each smaller box would be worth 10 beats. So you really have to make sure you're calculating the value of each small box in order to get an accurate reading. Okay, whew. Step 2 is a big one. There was a lot in there. If you need to stop, rewind, take a look at it again, stop and practice it right now, go ahead. We're going to move into step number 3. So all we've done so far was look at the rhythm of the atria and the ventricles, and we've calculated a rate of the atria and the ventricles. We know the normal heart rate for an adult is between 60 and 100. That's what we're hoping to see on our ECG. Okay, step 3 is simply to look at the P waves and observe them for the typical pattern we would expect. We mentioned that the P wave is round and upright. There is one for every QRS wave, and it should look the same all the way across. So if we take a look here, I've highlighted them in yellow. There's a P wave, round and upright, and there's one QRS, there's one T wave, and then we get a P wave. And as you carry that all the way through, you can find out that they are consistent in this particular ECG strip. So I would just write for my P wave that it is round and upright. And to note that there's only one for every QRS, I put a 1:1. One P wave to one QRS wave. That's the one-to-one conduction. All right, on to step 4 now. We're going to look at the QRS wave. Now this one is a measurement. I did mention in our last video that the QRS wave is typically between 0.06 seconds and 0.12 seconds. So I have a video playing here. All right, so we're going to take our calipers or your piece of paper at this point, and we're going to measure from that first deflection after the P wave. Remember, the P wave goes up and down, isoelectric line, and then the first movement off that line. It is going to include the R wave and the S wave, and when it comes back to isoelectric line, that's where we stop. So we're going to measure that all the way across. Make sure it's consistent, every single QRS all the way across. And then I want to see what the actual value is. So take that measurement, put your calipers on that pink line, and count how many small boxes you have. Step number 5 is, again, another observation. So the P wave and the T wave are simply observation. They should both be round and upright. And it should be consistent all the way across. Generally, they're about the same height and amplitude, but they don't have to be. And as we look at this one, P, QRS, T, P, QRS, T is what we're focusing on. It is consistent all the way across. So I would simply write round and upright. That would be my analysis of the T wave. Step number 6 is the PR interval. Now we need to look at our PR interval, and then next in step number 7 will be the QT interval. So I actually want to know how long is it taking for the atria to completely contract, and how long will it take then for the ventricles to completely contract. We're going to focus on the atria first. So this begins with the P wave, isoelectric line, and as soon as we get that first deflection off, that's the beginning of the P wave. When the P wave comes back to baseline, plus the flat line afterwards. That's all part of the PR interval. Now it usually is between 0.12 and 0.20 seconds in duration, and again, you need to go all the way across your ECG and look at every single one to make sure they are the same. After we're done that, we're looking at the QT interval, the ventricular time that it takes for contraction and relaxation. So this begins where the QRS wave starts and ends where the T wave comes back to baseline. Typical duration is 0.36 to 0.44 seconds. Again, checking consistency all the way across the ECG to make sure there's no abnormalities. Our final step, before we get to the final step, this is the part where we may have to correct this interval. This is the interval we may have to correct if we have too slow of a heart rate, less than 60, or too high. So if my heart rate is less than 60, the QT interval will be too long. So we need to correct it to make sure it is in the right range for that heart rate. If your heart rate is greater than 100, it's going to be too short because it's really, really fast. So we need to correct it again. And that's the formula. Now, step number 8 is to evaluate the ST segment. Remember, that's that flat line between the QRS, the ventricles contracting and relaxing. It begins at the J point, right when the S wave comes back to baseline, and it ends the moment the T wave leaves baseline. This should just simply be a flat line, and your analysis with this would just be nothing significant, or you can say flat. So this is considered the normal sinus rhythm. So if we look at this all again, in this table as a highlight, the rhythm for the atria and the ventricles will be regular. The rate of the atria and the ventricles will be between 60 and 100 beats per minute. The P wave will be round and upright, and 1-to-1 for QRS conduction. The PR interval will be between 0.12 and 0.20 seconds. The QRS complex, 0.06 to 0.12 seconds. The QT interval, 0.36 to 0.44 seconds, and the T wave round and upright with a flat ST segment. Now it is time to practice. You're going to go back into your booklet and you'll see Mrs. Jones' 12-lead ECG. Remember, we're focusing just on that bottom line, lead 2, which is a 10-second strip. Go ahead and complete your analysis and then answer all the review questions. Your answers you'll find at the back of your book. After you're done this section, we're going to move into arrhythmias.